Welcome to my channel, viewers. We are discussing the chapter 12 of class 8 Cbse curriculum. This is factorization of polynomials or factorization of algebraic expression. Now let us remember some algebraic identities like a square minus b square, right? This you can write as a plus b multiplied by a minus b. That means this is the factor form of a square minus b square, right? Similarly, you remember this identity a plus b whole square equal to a square plus twice of ab plus b square. That means when you are given an expression in this format, you can factorize like this. A plus b whole square means a plus b multiplied by a plus b. So if you are given an expression in this format, a square plus twice ab plus b square, then you can factorize it like a plus b multiplied by a plus b, right? Similarly, you remember this a minus b whole square equal to a square minus twice of ab plus b square. So if you are given a square minus twice ab plus b square, then you can factorize it like a minus b multiplied by a minus b, right? So using these algebraic identities, we will try to factorize a few sums here again. So let us consider this. Say for example, a square, example 1, a square plus 8a plus 16. Now you can compare this, it's a trinomial, right? So you can compare with this identity. So can we make it a perfect square like this? A square plus twice ab plus b square is a perfect square. So we can write it as a product of a plus b into a plus b. Now let us consider this identity, a algebraic expression. So can we make it a perfect square in this format? So this is first term is a square, it's a perfect square. So let's see the third term here. 16 is a perfect square. You can write it as 4 square. Now middle term should be twice of a into b, twice of the first term into second term. So you see twice of the first term means a multiplied by second term means 4. So it is a square plus twice of a multiplied by b plus b square. So you can write it as a perfect square, a plus 4 whole square. A plus 4 whole square means a plus 4 multiplied by a plus 4. So this is the factor form of this algebraic expression, right? Now think about this 4x square minus 8x plus 4. Now you can compare this trinomial with this identity, right? This is a square minus twice ab plus b square. If you can convert this into this format, a square minus twice ab plus b square, then we can factorize this like a minus b multiplied by a minus b. So first term, you see, first term is a perfect square. We can write it as a twice x whole square. And third term is, it is also a perfect square, 2 square. So middle term should be minus twice ab, minus twice of a means twice of x, b means 2, right? So this is a square minus twice of a multiplied by b plus b square. That means a minus b whole square, right? So we can write it as a minus b multiplied by a minus b, right? Again, you can take 2 as a common factor of this first term. So we can write x minus 1. Then this becomes x minus 1. That means 2 is a common factor of the second term also. So we will write it as a factor from 2 multiplied by 2 multiplied by x minus 1 x minus 1, right? Let's do one more example here. Say example 3, 121 b square minus 88 bc plus 16 c square. This you can compare with this trinomial a square minus twice ab plus b square. So if you convert this into a square minus twice ab plus b square, then we can factorize it like a minus b multiplied by a minus b. So you see 121 is a perfect square. 121 means 11 square, b square, 11 square b square means 11b whole square, right? Third term you can write it as 4c square, right? So middle term should be twice of a multiplied by b. So if you see twice of a, 11b multiplied by c means 4c here. Twice of a multiplied by b. Twice of a multiplied by b. So this is a square minus twice of ab plus b square. That means you can write it as a minus b whole square. First term minus second term whole square. So 11b minus 4c, again 11b minus 4c. This is the factor form of this trinomial, right? Sometimes you have to cross check it whether this product is equal to the middle term or not. You may find that this product may not be equal to middle term. In that case, you cannot use this identity for factorization. Say for example, if you are given suppose x square minus 3x plus 2 suppose, right? You cannot factorize this using this identity. This is not a perfect square. So even if you write it as a perfect square like this x square minus say for example square root of 2 whole square is 2. Now if you try to write the middle term in the form of twice ab, you cannot do so, right? Twice of a means x, b means square root of 2. Now twice of ab means 2 root 2x, but middle term is 3x, so it is not equal to this term. So we cannot convert this into a perfect square, right? We will do it in another format. We'll discuss in middle term splitting in the next video. So here we will discuss only perfect squares. Now let's do factorization of this. Suppose 4p square minus 9q square. Now this you can compare with this binomial a square minus b square. How did you factorize this? Factors of a square minus b square, a plus b into a minus b, right? So this you can write it as twice of p square minus 3q square. Both are perfect squares. So this you can compare a square minus b square. So it is first term plus second term multiplied by first term minus second term. A plus b into a minus b. A plus b multiplied by a minus b. Let's do one more example. Say 49x square minus 36. So both are perfect square here. 7x square minus 6 square. So a square minus b square. Now let us factorize this. A plus b minus a multiplied by a minus b, right? Then again, let us do it. Say for example, L plus m whole square minus 4lm, right? Now you see it's a perfect square, but second term is not a perfect square, right? So we cannot use this identity at the beginning. So let us try to simplify this. Let us simplify this. A square plus b square plus twice ab, right? A square plus twice of ab plus b square minus 4lm. Now let us simplify the common terms. Find the sum of these common terms. So we will consider this, we will group them together. So this is L square plus m square. This becomes minus twice of lm. Now you can compare with this a square plus b square minus twice ab, or a square minus twice ab plus b square. So you can write it as a minus b whole square. That means L minus m multiplied by L minus m, right? Now we'll do one more example here. Say for example, x square minus twice of xy plus y square minus z square. Now see, it's a perfect square, right? This you can write as a minus b whole square, x minus y whole square minus z square. Again you got two perfect squares. So you can compare this with this identity, a square minus b square. You treat this as a square and z square means b square. So what are the factors of a square minus b square? A plus b, a minus b. So here a means x minus y, a plus b, right? Then a minus b. So if you simplify this, x minus y plus z and x minus y minus z, right? And we will do one more example here. So it is 25a square minus 4b square plus 28bc minus 49c square. Now you see this term, it looks like twice ab, like a square plus twice ab plus b square, right? So let us treat this as twice ab. Consider this as twice ab. So let us group these three terms together. Why? Because the perfect squares contain here b and c, and middle term contain bc. So we can convert this into a format like this, or a square minus twice ab plus b square. So let us try to group them together. 25a square. Now if you put them inside bracket, this will become 4b square. This plus will become negative, minus 28bc, minus minus plus, and negative will become positive, 49c square. Now you can treat this trinomial, compare this with a square minus twice ab plus b square. So let us write this. Twice of b square, this you can write as 7c square. So it is a square, this b square. So middle term should be twice of a multiplied by b. So it is a square minus twice ab plus b square. So you can write it as a minus b whole square. Again you got two perfect squares here. So it's a difference of two perfect squares. So you can compare with this identity, a square minus b square. So this you can write as 5 of a square minus twice of b minus 7c square. So let us treat this as a square minus b square. So a plus b, a plus b, this is b here. Then a 5a minus b minus twice b minus 7c means plus 7c. So a plus b into a minus b. So factors of this quadrinomial is a plus b, a minus b. Let's do one more exercise here. Say for example, let us do it 9x square y square minus 16. So it's a binomial, so we'll compare this with a square minus b square. So this you can write as a perfect square, 3xy square minus 4 square. So this is a plus b, then a minus b, right? So thank you viewers for watching this video. We will do some more factorization using algebraic identities in the next video again. Keep in touch.